Okay, folks, for example number 4, it says find the GCF of 72 x to the third, y z to the third, and 120 x squared z squared. Okay, well, you know, I think the easiest way to do it is the way Miss Potter taught me to do it. Right? I mean, I could prime factor them and find all the common prime factors and then multiply that to get my greatest common factor. But honestly, I like doing the latter method. 72 x cubed y z cubed and then 120 x squared z to the fifth. I'm going to draw a ladder around that, or a rung of the ladder. And I know that 6 goes into both of those. So it's 6 times 12 x cubed y z cubed. And 6 times 20 x squared z to the fifth. All right? Definitely 2, it looks like 4 goes into 12 and 20. All right, let's see. 4 times 3 x cubed y z cubed. And then 5 x squared z to the fifth. So you see, I didn't have to pull out the biggest number. I just keep pulling numbers out until I can't pull numbers out anymore, which is where I am now. Because you can see 3 and 5, they don't have anything in common. But you see, I can pull x squared from both of those numbers, right? So it's x squared times 3x, that would give me 3x cubed, y z cubed, and then 5 z to the fifth, because see, I pulled out that x squared, okay? I pulled out an x squared from here, but it left me with 1. That's why I've got this 1 down here, all right? Now, I can't pull out a y because they both don't have a y, but I can pull out z cubed. They both have z cubed, so that's going to give me 3xy, okay? And then 5z, I still have 2 left in there, okay? Now, there's nothing left for me to pull out. So my greatest common factor is the product of those things. I just multiply them together. 6 times 4 is 24, x squared, z cubed. This is the biggest number that goes into both of these. Okay? Also, if this were a fraction, if it were 72, x cubed, y, z cubed, over 120, x squared, z to the fifth, then this is the fraction reduced. 3xy over 5z squared. Boy, that turned out really nice. Okay? All right. Nice job. We're ready for the next one.